Welcome to today's review lesson on solving linear verbal problems with one equation and as a system of equations. So to review, there's a few formulas that we have to know. We have perimeter, we have the area, and we have the total dollar amount, which is your cost times quantity. We also have consecutive integer let statements, both odd and even, and the regular consecutive. So one thing that we have to remember here is that if it's a consecutive integer, that means that it's one right after the other. For instance, consecutive integers would be like 1, 2, 3, and so on and so forth. Which is why for consecutive integer let statements, the first consecutive integer is always x. The next one would be x plus 1, because in order to go from 1 to 2, you have to add 1. And the next let statement would be x plus 2, because in order to go from 1 to 3, you would have to add 2. Now, in that same concept, we also have odd and even, which, as you know, the basic consecutive odd integers would be 1, 3, 5, and the basic even integers that are consecutive would be 2, 4, 6. And these ones are going to go up by 2. So x will still be the first consecutive odd or even integer, but the second odd or even consecutive integer would have to go x plus 2, because there are 2 integers in between. So 1 plus 2 is 3, 1 plus 4 is 5, etc. Okay, so for the first example, we're going to solve this using just one variable, which just means one letter. So we have the length of a rectangle is 2 feet less than 3 times the width. The perimeter is 204 feet, and we need to find the length and width of this rectangle. And again, it says solve using only one variable. So we're going to start with a let statement. And we have to figure out what do we want x to represent. And so we have to look at this problem and figure out what are we depending on. And usually that variable is going to appear at the end of a sentence. So if we read the first sentence, it says the length of a rectangle is 2 feet less than 3 times the width. So since length is depending on width, we're going to have our width be our x. So we're going to start off our let statement with let x represent the width. And now we have to use a let statement to represent the length. And as we see here, where it says the length of a rectangle is, we know that is represents the equal sign. 2 feet less than 3 times the width. Well, 2 feet less, remember that's always subtracting 2 at the end, from 3 times the width. And 3 times means we're multiplying our width by 3. So if we translate that into our let statement, we're going to say let 3x minus 2 represent the length. And our equation comes from this next sentence where it says that the perimeter is 204 feet. Well, we know the perimeter formula is perimeter equals 2L plus 2W. So if we use that, we're going to start off with the fact that the perimeter is 204 feet, so we'll have 204 equals 2 times the length, which we know the length is 3x minus 2. And then we also have to add in 2 times the width. And we know that the width is represented by x. Now, if you want to pause the video here, you can go ahead so that you can solve for the length and the width using this equation that we just created. Okay, so in order to solve this, we're going to start by distributing this too. So we have 204 equals 6x minus 4 plus 2 times x gives me 2x. Since the x's are on the same side, we're just going to combine them because they're like terms, and so 6x plus 2x will give me 8x. In the same step, and to save room, also going to add 4 to both sides so that I can isolate my x's. I will end up with 208 equals 8x, and in my last step, I'm going to divide both sides by 8 so that I can find what x is, which again, remember, is our width. And so 208 divided by 8 will give me 26. And since this is a word problem, we need units at the end. And we're talking about our width, which is in feet. So this is 26 feet is our width. Now, they also want you to find the length. So in order to find the length, since we know 3x minus 2 is the length, we know that x is 26, we can simply substitute 26 in for x. And so by doing so, we have 3 times 26 minus 2, which will give me 76 feet. Because remember, we need our units. And this is our length. So the length of this rectangle is 76 feet, and our width is 26 feet. Now, question 2 says, solve example 1 as a system of equations with 2 variables. So essentially, we're going to obviously get the same answer in the end, but we're going to use 2 variables to show that we can also solve this with a system of equations. So, since we're going to have 2 variables and we're talking about length and width, we might as well use L to represent our length like we're normally used to, and we're going to have a let statement of W represent our width. So, if we look back to problem 1, where it says the length of a rectangle is, we know again, equals 2 feet less than 3 times the width, well, that is going to be L equals 3 times W minus 2. So that's the one equation. And the other equation that we have, again, is from the second sentence where it says the perimeter is 204 feet. So that's going to be 2L plus 2W equals 204. And now, to solve this system of equations, we're going to use the substitution method, and we are going to substitute this 3W minus 2 in for L in the other equation. And so what that looks like is 2 times 3W minus 2 plus 2W equals 204. Now, to save time, I know that we can easily distribute, combine like terms, solve for W, and then in turn find L. So I'm not going to make you continue. I just want you to be aware that there are 2 ways of solving it. And so in the future, you can choose either option, whatever you decide works best for you. So number 3 says that Alex buys 2 donuts and 3 cupcakes for $3.30, where Brian buys 5 donuts and 2 cupcakes for $4.95. And we're going to find the cost of each. So We'll start with our let statements, and we're going to use two different letters and solve this system of equations. So let's just use D to represent the cost of a donut, and let's use C to represent the cost of a cupcake. Now, it's important with your let statements that you don't just write donut, cupcake. You need to represent whether it's the cost, the quantity. You have to be specific in what you're finding. So now, if we create the equations, this is our cost times quantity equals total concept. So if we have, for instance, 2 donuts, so 2 times donuts, which we don't know the cost of a donut, so that's just D, plus we have 3 cupcakes, so 3 times the cost of a cupcake is C, equals the total dollar amount of $3.30. The other equation is going to be the fact that Brian bought 5 donuts, that's 5 times D, plus 2 cupcakes, 2 times C, and spent a total of $4.95. Now, in the last problem, we set that up with substitution, but we're actually going to use a different process here. We are going to use elimination to solve this problem. And if you remember with the elimination method, what your goal is to do is to figure out a way where you can add these two equations together so that one of the variables will cancel out. And so you need to figure out what you want to cancel out, whether you want C's to cancel or the D's to cancel. So in this problem, I'm probably going to cancel out the C's because we can work with smaller numbers to multiply. So what we're going to do is, in order to cancel out the C's, I'm going to multiply this top equation by 2, and I'm going to multiply the bottom equation by -3. And that way, my C's will turn into 6 and -6, and when I add the two equations together, they're going to cancel, and then I can solve for D, the cost of a donut. So I'm going to write my work down here. And so when I distribute and multiply every term in the top equation by 2, I'm going to get 4D plus 6C equals 660. When I multiply the entire bottom equation by -3, I will get -15D minus 6C equals -1485. Now we're going to add the two equations together. And again, this is the elimination method. And so by adding them together, you'll see that the C's will cancel. And when you add 4D and -15D, you're going to end up with -11D equals -825. And in the last step, we'll divide both sides by -11, and we will end up with D, which again was the cost of a donut, is 75 cents. So since they want you to find the cost of a donut and a cupcake, we are now going to find how much a cupcake cost. And here you can choose either equation, whatever you decide is easier. I'm probably going to choose the top equation because, again, it has smaller numbers. And so by using the top equation, that 2D plus 3C, I'm going to start off with 2 times, now instead of D, I'm going to plug in 75 cents, plus 3C equals 330. So when I solve here, 2 times 0.75 is 1.5 plus 3c equals 330. I can then subtract 1.5 from both sides. I'm left with 3c equals 1.8, and when I divide both sides by 3, I will get an answer of c equals 60 cents. So I found that the cost of a donut is 75 cents and the cost of a cupcake is 60 cents. Okay, so the last question is the sum of 3 consecutive odd integers is, again that's equals, 18 less than 5 times the middle number. Find the 3 integers. So before we come up with the equation, we need the let statements. So since there are 3 integers to find, we're going to have 3 let statements. And it will always start with let x be the first. And in this case, it's consecutive odd integers. So we're looking for an odd integer. Because it's an odd integer, they're going to go up by 2's. So the second integer that's odd will be x plus 2. So that's going to represent the second. And x plus 4 then would have to represent the third. So as we read this, this is, right here, is a big divider. It's going to divide whatever is written to the left is on the left-hand side of the equal sign, and whatever is written on the right is on the right-hand side. So where it says the sum of 3 consecutive odd integers, that will be on one side of our equation. So that's going to be x plus 2 plus x plus 4. Then we have that equal sign. 18 less than is always subtracting at the end, and that's what we tend to mess up on. Then we have 5 times the middle number. Well, the middle number here is that x plus 2. So we need to multiply 5 times our entire x plus 2, which is why we're going to keep it in parentheses, and then we're going to subtract 18 at the very end. Okay, so now to solve this. If you want to pause here so that you can solve this on your own, feel free. Otherwise, we're going to do this together. So on the left-hand side, we can combine like terms because we have 3x's plus 6. And on the right-hand side, when we distribute this 5, we're going to have 5x plus 10, and we can't forget about the minus 18. So over on the right-hand side, we still have like terms. 10 minus 18 will give me a negative 8, and so I have 5x minus 8 on one side, 3x plus 6 on the other. I'm going to subtract 3x from both sides, and in the same step, I'm going to add 8 to both sides so that I can isolate my x's on one side, my numbers on another. So I have 2x equals 14. When I divide both sides by 2, I end up with 7 as my x value. And since they want us to find all 3 integers, well, if I know that my first integer is 7, then my next odd integer, 7 plus 2, will give me 9. And my final odd integer, 7 plus 4, will give me 11. So my 3 consecutive odd integers are 7, 9, and 11.